Okay, so continue the chapter 5, component number 4, detectors. Some detectors are universal. They are sensitive to almost every compound that elutes from the column. They are sensitive to a particular type of a compound, give response that is dependent on the concentration of analyte in the carrier gas. So the ideal characteristic of detector is high reliability and easy to use. Similarity response towards all solutes or alternatively a high predictable and selective response toward one or more classes of solute. Detector should be non-destructive. Adequate sensitivity, good stability and reproducibility, a linear response to solute that extends over several orders of magnitude, a temperature range from room temperature to at least 400 degrees C, a short response time that is independent of flow rate. So a type of detector, FID, flame ionization detector, TCD, thermal conductivity detector, and lastly ECD, electron capture detector. So for the FID, usually for organic molecule, TCD can be for any sample, and then for the ECD, sensitive towards the electronegative element. Right, so for FID, the principle of operation, effluent from the column is made with the hydrogen gas and air then ignited. The organic compound burning in the flame creates ion and electrons which can conduct electricity through flame. The burner held at the ground potential acts as one of the electrode. The second electrode called as a collector is kept at the positive voltage and collects the current that is generated. Lastly, the signal amplified by the electrometer that generated measurable voltage. The advantages: rugged, sensitive, wide dynamic range. Signal depends on number of carbon atoms in organic analyte. Mass sensitive, not concentration sensitive. However, the disadvantages are weakly sensitive to carbonyl, alcohol, and amine group, not sensitive to non-combustible analytes such as water, CO2, SO2, and NOx, and then it is thus a destructive method. For the TCD, consists of electrically heated wire. Operating principle relies on the thermal conductivity of the gaseous mixture. When the solute elutes from the column, there is a change in the composition of the mobile phase and thermal conductivity, resulting in a deviation from thermal equilibrium, causing a variation in the resistance. This variation is proportional to the concentration of the analyte. The advantages are simple, large dynamic range, respond to both organic and inorganic, non-destructive. Disadvantages: low sensitivity. Then for the ECD, the principle, sample elute from the column is passed over a radioactive beta emitter, usually nickel 63. An electron from the emitter causes ionization of carrier gas and the production of a burst of electrons. In the absence of organic species, a constant sending of current. However, in the presence of organic molecule containing electronegative functional groups that tends to capture the electron, the current decreases markedly. The advantages are selectively respond to halogen containing organic compounds such as pesticide and polychlorinated biphenyl, highly sensitive to halogen, peroxide, quinones, and nitro group, but the disadvantages are insensitive to functional groups such as amine, alcohol, and hydrocarbon.